This is example 3 from page 13. This is our third example from the arithmetic sequence section, 1.1. And in this case, we're going to determine the first term. We're going to determine an expression for the nth term. And we're going to see exactly how many terms we have in the sequence. Okay, this isn't a sequence that continues on. It's going to have a given number of terms. And so we're going to figure out how many there are. Okay, we have a diagram here that shows us the top 6 rows in this display. Okay, I'll read you the question. Jonathan has a part-time job at a local grocery store. He's been asked to create a display of cereal boxes. The top 6 rows of the display are shown. The numbers of boxes in the row produce an arithmetic sequence, and there are 16 boxes in the third row from the bottom. Okay, so we have some information there. You can see how the number of rows is changing, or the number of boxes in each row is changing. That statement about 16 boxes in the third row is a really key piece of information, because that's actually going to help us figure out how many rows there are. Okay, so when we do the questions, we're going to start off by writing out what we know about this sequence. Okay, we're looking for how many boxes there are in the bottom row. Okay, so if we consider that the bottom row is going to be the first term in our sequence, then we'll call that T1. Okay, so that's really what we're looking for. That is the number of boxes in the first row. Okay, and we know, I'll just jot down here our arithmetic sequence term formula. Okay, we would take the first term. If you want to find the nth term, we're always going to take the first term, and we will add the common difference, and we'll do that n minus 1 times. Okay, so n minus 1 times the common difference. So if we can figure out what the values of some of these variables are, we should be able to figure out our unknown information. Okay, so let's list what we know, and we're looking for T1. Okay, we also know that T6, that's, the number of that's T3 is 16. Okay, so we don't know what the first term is, but we do know what the third term is, and so that's going to be an important piece of information. And let's see if we can find the common difference. Okay. One good way to do it is to just look at this drawing right here, or you can look at the drawing in your book if you want to look at a nicer one. But what you can see is that as we go further away from our first term, we're always going to be subtracting 2. Okay, and so if I were to list those terms, okay, I wouldn't know what my first term was. I wouldn't really know how many I had, but my later terms are 12, 10, 8, 6, 4, and 2. Okay, and so I can see, just from having those terms and knowing that those are consecutive terms, I can see that I always get from one term to the one after it by adding -2. Okay, so that tells me another important piece of information about my sequence, and that's that D is equal to -2. Okay, so now we pretty much have everything that we need. Okay, if we want to use this formula for the nth term, okay, you can use that. When you use that, what you want to do is pair up a term with where it sits in the sequence. Okay, so we can use this, and if we put n equal to 6, then we can use our value for T6. Okay, so let's just write that out. The 6th term, I'm not going to put the numbers in yet because I just want it to be really clear. The 6th term is going to be equal to the first term plus 6 minus 1 times -2. You might not write out that step, but I'm going to. So I know that my 6th term, sorry, I said that that was the 6th term. That's the 3rd term. The 3rd term is going to be equal to the first term plus 3 minus 1 times -2. Okay, so 16 is going to equal T1 plus 2 times -2. 16 equals T1, and I'm just going to multiply that, -4. We're going to add 4, and so T1 is going to be equal to 20. Okay, so we know that the number of boxes in the bottom row is 20. Okay, so the number of boxes in the bottom row is 20. Okay, let's see if we can get the rest of this done in a reasonable amount of time so this video doesn't get too long. Okay, determine the general term for the sequence. Well, this should be pretty easy. This we just want t sub n. Okay, and remember, in general, that means we want it to work for any n, so we're just going to leave n as a variable. Okay, we know that t sub 1, the first term, is always going to be 20 now. That's a feature of this sequence. Okay, that's one of the characteristics that makes this makes it this sequence. And d, negative 2. Okay, so we'll just simplify this by distributing that negative 2 here. Okay, be careful when you're distributing that negative. Okay, so we're going to have negative 2. Let's fix that. Negative 2 times n is negative 2n, and then negative 2 times negative 1 will give us a positive 2. Okay, so the nth term is given in general by negative 2n, and we'll group these two like terms together, plus 22. Okay, so we can always find any term if we know its position by substituting the n value into this expression. Okay, so that would be our general term for the sequence. Okay, and then how many rows are there? Okay, how many rows are there in total? Well, in this case, what we're going to do is knowing what our last term is. Okay, and we know that our last term is 2 because that's the top row. We want to know what is the n that corresponds to that. Okay, the first term of the sequence is still going to be 20, and the common difference of the sequence is still negative 2. Okay, and so just a simple matter of substituting that in. Okay. I just moved that over to a new page to give us a little bit more room here. Okay, that was getting a little crowded. So I'm just going to leave the n minus 1 intact. Normally I would distribute, but I think I'll just leave it as it is. I'm going to subtract the 20 from both sides. Okay. So negative 18 is equal to n minus 1. Yeah, I'll just leave the brackets for last times negative 2. And I'll divide both sides by negative 2, so that factor cancels. Okay, this becomes 9. This becomes n minus 1. And then when we add 1 to both sides, we get 10. So the number of boxes in the display is 10. Okay, the number of rows are 10 rows in the display. And that's the end of the question.